if we're only looking at total white blood cells, this is generally an informative measure of quote unquote immune cell health, because unless you're way too high or way too low, and plus, white blood cells as a group are a heterogeneous population of cells. So neutrophils and monocytes increase during aging and lymphocytes decrease during aging. So if you're only looking at total white blood cells during aging and their counts, you're going to miss those age-related changes, and then it's probably too late. But then we can even further subdivide lymphocytes into CD4, CD8, NK, B cells, and then you could even dig deeper into monocytes, which is on this chart here. Okay, before going there, so the importance of digging deeper for those who don't know, for lymphocytes, for example, in looking at CD4 cells, rejuvenating CD4 cells in Alessio Lana's group, granted, it's still in the preprint stage, but I'd be shocked if this data didn't end up panning out once it hits a publication, was that rejuvenating CD4 cells, CD4 T cells, which are a type of lymphocyte, dramatically extended lifespan, even to a magnitude greater than calorie restriction or any intervention, including rapamycin. So then it becomes, okay, what do these immune cell subtypes, these further subdivisions of lymphocytes and other cells, other immune cells, how do they look in centenarians, which you've got up here as EL, extended or extreme longevity, when compared with younger, middle, or older age groups? So I think I've shared this with George because this is from one of George's papers. I think it would be informative for people to see how these immune cell subtypes change during aging, especially for people who are interested in not just measuring their total lymphocytes, but also commercially available labs. We can measure CD4, CD8, NK, and B cells, but then they're going to be like, what do I do with that information? How does it look in centenarians? What's good? What's bad? So I was hoping to get your thoughts, and I know most of that answer, so it should make for a good discussion, but it would be good to get your thoughts on how each of these things changes during aging, and then how centenarians either resist or it's further worse for them. So let's start off with the CD4s, because I think there's a growing body of literature where having them youthful and or rejuvenated, as I mentioned, is a big part of longevity. So let's go through what happens to the CD4s, and the pattern is similar in the females and males. So if you could just walk us through what happens to CD4 levels and then how it differs in centenarians.
Sure. So I remember when we published this was a lot, right? So this is basically looking at proportions, right? But if you look at the overall sort of schema of blood cell and immune cell development, right? So I'm a hematopoietic biologist, which includes blood and immune cells. It's like my favorite thing. I think all the answers, including why these people might be long-lived people, has to do with their immune system, right? So to sort of take it back a step, we saw that there was a decreased ratio, as you just explained, of lymphocytes, right? That's a category that's like your T cells and your B cells to myeloid cells, right? So we always know that part of the innate immune system, that happens with age. So a normal change that you're going to have just sitting here is that decreased ratio of lymphocytes to your myeloid cells, right? So this was an expected change, but then, okay, in contrast to maybe the interpretation of this as far as the different proportions, okay, we saw that centenarians had more B cells. Okay, your B cells, explaining the way that you did, they're cells that produce antibodies. We'll just look at that in a very simplified way. And fewer T helper cells, right? So more B cells, fewer T helper cells. Those are cells maybe that help coordinate other immune cells, sort of activate to a particular immune insult, compared to younger people. Okay, so that change was not just an age correlated change, but it was a change that was unique to centenarians, male or female, right? And that did not occur in older centenarians, right? So I think I'm going to get to something that's really kind of controversial in a second, but our overarching thing, and this gets back to what I was saying about some of these people having had the Spanish flu and also COVID, right? So we think these types of shifts, right? When you put them all together, if you look over a lifetime of a centenarian, somebody that lives 100 years or more, this has trained their immune system to be faster, to be more effective to dealing with insult or infection, right? So if somebody's 100 years old and they get COVID, their immune system has been trained to an elite status for more than 100 years. And if you have more B cells, maybe, just maybe, they would respond faster to infections than T cells. Okay, the other thing that I'll say, which is related to having a more rejuvenated T cell, right? So if you look at cell numbers in centenarians versus non-centenarians, you had one of the striking things that we saw was you had more CD14 positive macrophage, that's a blood immune cell, and you had more cytotoxic T cells, right? So that's a distinct shift that another Japanese group who profiled centenarians, they also saw, right? And what this brings me back to is how you could have maybe it's not about the proportions, but it's about the fitness of the cells themselves, kind of what you were alluding to, right? So if you had a way to maybe rejuvenate your immune system, to reconstitute maybe the initial diversity of blood and immune cell types you had, that would be better, right? So this is where I'll introduce something called CHIP, right? So for your listeners, CHIP stands for clonal hematopoiesis of indeterminate. Um, I don't want to use the exact nomenclature, but people don't know sort of where it came from, right? So conceptually, the idea is as you age, the diversity of your blood cell types becomes smaller and smaller. And why that is your hematopoietic stem cell, which is your master blood stem cell, fewer and fewer of those remain functional. So what happens is your entire blood system, which is trillions and trillions of cells, end up getting produced by fewer and fewer hematopoietic stem cells. And that is dangerous. That's normally equated with smoldering issues like CHIP, but with leukemiogenesis, blood cancer, or with cardiovascular disease. So the less diversity you have, the more of your cells that are created from fewer and fewer hematopoietic stem cells, the more that's equated with mortality. Okay? So when we went to go look at centenarians, okay, this is a very long-winded explanation, we thought for sure centenarians would have way less of this clonality, that they would have more diversity of their hematopoietic stem cells, and that would explain everything because they don't go through this clonality and badness that results in a normal person. Turns out centenarians have more clonality, and you can trace back some individuals that their current entire blood system is created from one or two HSCs, which you'd think, me as a hematopoietic biologist, is super destructive. Can't be good because you're going to have an accumulation of mutations and whatever. But the hypothesis we have now, and I have no data to prove this, but we're working through it, is just like you can have detrimental mutations that lead to leukemiogenesis, blood cell cancer, cardiovascular disease as you age and as you increase this clonality, that you can also have mutations. So the one thing that we didn't see was these detrimental oncogenesis driver mutations in the centenarians that led to the clonality. You had this massive clonality, but it was driven by other things that we think might be making a more fit progenitor cell, which can then go on to produce a more fit T cell, kind of like what you're saying, right? So they kind of naturally might produce or rejuvenate their cells because the origin of their cells are from these elite HSCs that have increased functionality.
Stemness factors, I guess you would look at stemness factors in the HSCs, whether it's, I don't know, TCF7 or, I can go down the list, RUNX1 or.
Yeah, so that's one of the things we defined. The two people I started the CREM with, we were in Richard Mulligan's lab at Harvard, and that's what we worked on. We worked on side population staining, or what are the elite markers of an HSC. So if you look at a mouse, for example, okay, here's the interesting thing. If you look at a young and an old mouse has way more hematopoietic stem cells that you would mark by all the things you mentioned and all the markers of the classical markers of a bona fide blood stem cell. But even though in that aged mouse, you have way more HSCs, far fewer of them can reconstitute a mouse, right? So that's the gold standard. And why I love blood is that you can run the gold standard assay of gold standard assays, which is you can irradiate a mouse, kill its bone marrow and its blood system, and then reconstitute that mouse, if you wanted, with a single functional HSC, which would then repopulate the blood system of the mouse, right? So the really interesting thing is that even though you have more HSCs, they become less functional over time. So card-carrying, marker-bearing HSCs, but they don't retain that same functional quality of the cells that are in the younger mouse. And so you can imagine in a centenarian, you have some type of mutations, which we don't know what they are yet, but they don't seem to be pathogenic, that create a better, more fit HSC, which is kind of like maybe a younger or more functional HSC, which then goes on to make higher order CD4 T cells maybe, or cells that have more rejuvenative or the capacity to deal with or adapt to these insults, right?
So those HSCs, those one or two that are, somehow surviving in the centenarians, I mean, is that the golden ticket where if you figure out the mechanism for why they're maybe younger people, all of their HSCs are gone, they can't make the immune cells that they need, they can't be resistant to infection as a part of that story, and then they die, right? So is that how, yep.
Yeah, and so I think that also connects into that concept of everybody loves the word inflammaging, right? So as you get older, you have, remember we talked about that level of entropy or background noise, which kind of everything we look at in a centenarian is lower. We see that in the immune system as well, which is the more inflammation that you actually have, the more non-productive inflammation that you actually have, right? That's like basal inflammation that exists over a period of time. That's definitely equated with mortality, autoimmunity, cardiovascular disease, all these other things, right? So in a centenarian, if you have this much more elite system, which is more like a rejuvenated or young system, you're less perturbable with things that would create this kind of non-specific inflammatory response, which you don't want, right? So maybe that's part of the equation as well, is that you have less inflammation, you have a more elite immune system that has better CD4 cells that are not misprimed to sort of go off and, kind of inappropriately activate other sort of immune qualities that are off when they need to be off, but can regulate and can functionalize to a much higher order than you or I because they have this, rejuvenated quality of functionality.
Yeah. So wait, are you studying those HSCs from centenarians and to see what makes them functionally, I guess, elite compared to younger age groups or even centenarians who died at a younger age?
We're trying in different ways, and the way that we're doing it is kind of like a back end way. So we can create these sort of cell trees where it's a really cool process where with single cell data now, you can look at the repertoire of blood cells from anyone, from you or I or from a centenarian, and that's a non-invasive thing. The way that we figured out how to make iPS cells was great because you didn't need to have a skin punch biopsy. You don't want a skin punch biopsy a centenarian, by the way, right? So we just take a very non-invasive blood sample. You can make an iPS cell, but you can also profile those cells and look in various ways to know what the origin of those cells was, right? Based on a bunch of different parameters I'm not going to get into, but you could trace back in a cell tree lineage sort of tracing way without, oligo tags or something to kind of understand the production of those cells, right? You can do uncoupling bioinformatically or something, right? So it's impossible, even from a normal person. I'm not going to capture your HSCs, which would be an incredibly invasive procedure. I'd have to mobilize you, and all those things are dangerous. You'd never do that for a normal experiment. And so obviously for a really sensitive centenarian, we can't kind of go in there. What we can impute sort of the clonality based on the outcome of the cells. And that is what we're studying. And so we make blood, right? So we can, going back to our origins, we're now trying to actually look at centenarians, recapitulating blood and immune cell development, and see if we see the same outgrowth of elites or differentiated cells where you have a different repertoire of cells. And that's how we'll study it. So we'll study it in the same sort of ex vivo model where we model blood cell development in a dish, which we hope recapitulates the way it's happening in the centenarians.
Nice. Awesome. All right, hang on. If I heard you correctly, I think you said there was an increased proportion of B cells in centenarians, but I think the B
Yeah,
cells here are purple, right? So if you look at
it's all the
young,
purple. Yeah.
yeah,
Yeah. So
yeah.
yeah.
So if you look at the total purple, it's 4.3%, just looking at the female data, 4.3, 7.1, 14.1. But then in the centenarians, it's only 3.5% B cells. So they would have lower B cells, but I think I heard you say they had higher proportion of B cells.
Yes. And so I think and that's why this is a little bit confusing based on the estimated proportions. But if you look at everything in aggregate, again, centenarians, and this is a centenarian specific effect, had like overall looking at aggregate, more B cells and fewer T helper cells, right? And so that change was unique to centenarians and wasn't one of the age specific effects that we use because we harmonized data over decades of every age group, right? So again, there's the normal changes that you would see, which are recapitulated in many systems of age. But one of the specific differences that we saw, more cytotoxic T cells, more CD14 positive macrophage and monocytes, more B cells, fewer T helper cells, right? So the conceptual thing there is maybe you had a more elite methodology of responding to insult or infection.
Yeah, I get that. Wait, and all of that makes sense on the plot because I see the M14 monocytes in pink, 9.1, 8.8, and then 11.1, 17.1. And the data increases also for the males too, right? So I get what you're saying about an increased proportion of the M14 monocytes, which makes sense. You're chasing maybe more microbes, systemically because the immune system is just weaker or whatever. But the B cells, I'm still hung up on the B cells because to me, it looks like there are less B cells in the centenarians compared with at least the older age group, and even maybe at the same proportion as in young subjects. So how
Yeah.
am I? Yep.
So I think what this is this was one of the things that we made in the revision. And so one of the things that we use the spectral flow for, which again is antibody mediated flow cytometry, in which you designate some of these individualized populations. And I know that because this was the only way that we could convincingly break down the different populations of CD4 and CD8 cells. So this may be in contrast to what we saw transcriptionally, right? So that could be one of the reasons why it was different. But again, proportionality versus the overall number of things that we saw in aggregate across things, maybe transcriptionally, might be the reason why it looks a little different.
But the reason I hear you there, but if it's so if it's really that B cells increase during aging, which would be the opposite of what I see on the plot, the reason I'm raising that issue of B cells is because there was a paper that was recently published that showed that B cells drive CD4 immunosenescence, and then that's potentially important because, as I mentioned earlier, rejuvenated CD4s are a part of that pro longevity longer than every other intervention in mice. And also calorie restriction dampens down B cell levels, which suggests that maybe if in EL they have lower B cell levels, they'd have less CD4 immunosenescence, and maybe that's a part of their pro longevity approach. So am I misinterpreting that, or what are your thoughts?
No, I mean, I definitely hear that. And I'm definitely on the same page as far as the concept of a rejuvenated CD4 cell, right? And so in that complicated explanation I gave about clonal hematopoiesis, which is normally seen as a bad thing, I think maybe in centenarians, there's evidence to suggest that it could be causal in a productive way. And one of the ways that would result is that you would have more functionalized. Rejuvenated is a word that everybody uses. It's a hard word when you're looking sort of at steady state in this conceptual idea, but maybe the cells that you're creating from these elite HSC starter cells are resistant to aging, or basically have a more rejuvenated quality, or come from a higher order HSC that's more functional to begin with. And you had kind of alluded to that, right? So you end with the same result, which is a more elite CD4 cell that doesn't have sort of the age associated properties that would lead to, deterioration or something. So
So that would be
you have kind of in-house rejuvenate an in-house rejuvenation or de-aging program based on the genetics of your HSCs that are producing the daughter cells downstream.
so that would be a pathway independent of B cells negatively impacting CD4s.
Yes, but would still end up with the same kind of result, where if you're, eliminating some of the non-functional CD4 cells, basically through a kind of a targeted senescence pathway that leads to some kind of rejuvenation, it's a similar sort of thinking as far as how you would end up with a more elite immune system.
Yeah. So
But yeah,
then, so
I,
then Nice. So cytotoxic T cells was a new one for me because you can see, so the cytotoxic T cells would be in dark blue. And if you look at it at younger ages, at all younger ages, I mean, it's virtually absent at young, 0.3%, 1.5%, 2.6% in the females, and then it jumps to 7.5%. So I mean, that's a new concept to me. So it's got to be a new concept to most people. So what's the specific role of cytotoxic T cells that there's this dramatic expansion in the centenarians?
yeah. So again, I think it's a super interesting, and maybe one of the things we're thinking about with centenarians, and what's really interesting for me as a non-geneticist, is there doesn't seem to be a magic bullet, like a one particular thing that leads you on this pathway to being a centenarian. So we see a good amount of heterogeneity in the population. So now we're thinking about this multiple paths to sort of maybe getting to elite immunity. So I think one of the ways you could also hypothesize that you could also get this elite immunity is that, in the basal state, you have very less basal activity, no smoldering, inflammaging that leads to something. But then maybe you have, these cytotoxic T cell soldiers that are these elite soldiers that you have more of, and you have more diversity and more sort of a repertoire of this particular population in a centenarian that doesn't decrease the way it does with other people. And these things have this additive elite way to sort of deal with some of the insults that you have over time, right? and you just retain the quality of these cells to respond to these emergent situations like COVID or the Spanish flu or things of that nature, right? So I think the challenge is understanding exactly how you retain this elite immunity. And I think for us, the the conceptual idea is that it's not just a genetic thing and you're bestowed with this amazing immune system that just works this way, but it's adapted itself. It has sort of the underlying genetics and propensity to be able to train itself over decades to respond in a very different way, like this elite way in which it's very specific. It doesn't respond until it needs to, but when it needs to respond, it responds with, efficacy and power because of the fact that you have the repertoire of cells that you need, and you are different for some reason. You have more functional properties, maybe. It's an
Yeah.
interesting.
Oh. Yeah. So definitely along those lines, and it may be a simplistic experiment or a simplistic thought, but in terms of those CD4 cytotoxic cells that increase, and with the mechanism you just mentioned, that they're maybe a part of that phenotype that really helps give them that ability to chase down infections and respond to insult. Did you look at associations between the levels of CD4 cytotoxic cells with the things that increase during aging, like, for example, the NK cells, which are in green? You can see that they jump to 20.8 and 28.9% in centenarians. And then also, the M14 monocytes, which both of those cell types would be predicted to be, quote unquote, pro-inflammatory as they're chasing down microbes. So I wonder if the ability to have higher levels of CD4 cytotoxic cells could be a compensatory mechanism if your phenotype is JFC. I'm like talking in text speak. JFC, like we've got this massive burst of NKs and monocytes. We're chasing down microbes like crazy. But if we have this burst of the CD4 cytotoxics, maybe that's a part of counteracting that. Whereas centenarians that might not have as big of a robust CD4 cytotoxic response, maybe they die off sooner. So have you looked at maybe associations between the cytotoxic and the levels of the NK and the M14 monocytes?
We have not, but I love your thinking, and I think the immune system is so complex. It's elegant in its complexity and simplicity, really, in some instances when it responds, right? So again, one of the new papers that we have coming out, that actually is coming out and has been in review for what seems like 100 years, is a paper in which we could actually make not just T cells, but we can make both CD4 and CD8 T cells. And we're also trying to make very specific subsets of T cells that would sort of phenocopy the functional properties of the cells in you and I, right? And so we think we're all the way there. It was a slog to sort of go through these different developmental ways. It turns out it's really easy to make an NK cell, and everything that you actually do from an iPS cell just trips to NK identity. You have to kind of steer the ship in a completely different direction, not just to get a CD4 cell, but to have a cell that's capable of then going through switching and sort of repurposing and reprogramming itself at that point. So now we think we can do that. So again, one of the things that we think the system might be good to do is not just to model the dynamics of maybe how HSC growth and development might be different in centenarians, but now we can actually make B cells, T cells, different subsets of CD4 and CD8 cells to try to understand maybe how this is all working. Like, can we create an ex vivo model that could then be imported into a mouse, and to look at sort of reductionist ways of how the functional properties of these cells might be functioning in the people. And again, it's a very reductionist way, but now we can make many of the different subsets that might be involved here. We know how to make macrophages, for example. So we can now make, after 10 years, maybe the entire repertoire of the immune cells that we might need to model exactly maybe what we're seeing here. And then, of course, we have the iPS cells from these elite responders to see if we can recapitulate some of these dynamics, maybe outgrowth of those, cytotoxic T cells versus some of these different proportionality. Does that happen if you let it play out in a dish?